In this video, I'm going to go through some of the most tricky questions that were asked in the 2024 papers, the Cambridge IGCSE math papers. There might be other ones that are more tricky, let me know, and I can make videos on them. But these ones I felt were a little bit different than usual. I know this is not going to be easy to read, but I did make a PDF with these questions in. You can download it in the link in the description below. And I advise trying them on your own first and then coming to look at this video. I think the all-time worst question is also part of this group, but I did make a separate video on that one, but I'll talk about that when I get to that one. So for first one, it just says two parcels are mathematically similar, and there's a large and a small one. So I'll just start with some headings. So small and large, just making my life a little bit easier. And they say the volume, so this is going to be V for, okay, let's just write volume. Okay, volume. The volume of the larger one is 80 cubic centimeters. And the height, which would be a length, is going to be 5.2 centimeters. And then they said the smaller parcel has a volume of 33.75 cubic centimeters. Now with similar shapes, always have to be mindful of what scale factor I'm using. So for length, if I have one for length, it's not going to be the same for area and the same for volume. If I have it for length, I have to square it to get to area and cube it to get to volume. In this case, I have volumes. So, and I want to work out the smaller one's length. So for me, the easiest bit is kind of just writing the length. This is the unknown, right? So I would go and write this number. So 5.2, I'm going to multiply that by some scale factor. Don't know what that is, to get my length answer. So this is a length multiplied by the scale factor for length. And then I would have a length as an answer. Okay, so that's kind of what's going to happen here. Because I'm going from a bigger to a smaller one, I'm going to use these two. They're going to be my scale factor. And I'll put the smaller number at the top. So 33.75, and I'll put the bigger number at the bottom, 80. Because I know if I multiply by this with a smaller number at the top, I'm going to go to a smaller length here. And I'm trying to go from large to small. But there's a catch. I can't just use this scale factor, just the volumes on their own. I have to cube root it because I have to get the scale factor for length. So basically just 5.2 cube root of the, let's say the ratio between these two. And if I type that into my calculator, I would get a number like 3.9 centimeters. So yes, not extremely difficult, but it does catch out a lot of students because they get confused with the scale factor. Next one is a simultaneous equations question. And usually when we see them, we have linear equations. You probably can't see them, so I'll write that a little bit bigger. So we have 4y plus 3y is equal to 13. And the other one is y is x squared minus 18. Now, usually we can use, well, the first thing is I said usually we get two linear equations, but this one is a linear and a quadratic. So that is why at the bottom here we see we'll have two x values and two y values. Basically, this is a straight line and this is a curve, and we're just kind of asking in a different way, hey, where does the straight line and the curve cross? So easiest here would probably, oh wait, that's not a y. Sorry about that, that's an x. Sorry about that, 3x. Yeah, let me just double check. 4y plus 3x is 13. Y minus x squared minus 18. Okay, cool. So easiest here would just be substitution. This is already in the form of y. So this thing is equal to that thing. So I'm just going to write this out. I'm going to write 4 from my original, let's say, equation there. And I'm going to put a bracket and put whatever that y is equal to. X squared minus 18 plus 3x is 13. And this is a normal quadratic equation. when I multiply this out, I should get 4x squared minus, what's 18 times 4? 18, okay, that should be 72, plus 3x. I'm just going to bring this 13 over, minus 13 is 0, and just kind of turn this into the normal quadratic equations that we're used to, plus 3x, and then minus 85. Usually there are three ways to solve this. One is just normal factorizing. The second way would be the quadratic formula, and the third way would be completing the square. In this case, I don't think this is gonna factorize nicely, so I would just do the quadratic formula. So for the quadratic formula, I know this is my a value, so a is going to be 4, b is going to be 3, and then c would be, remember, it's negative 85. And now it's just filling it in. So again, this is straightforward, I think, but 5-mark question, don't get this one wrong. So this will be negative 3 plus or minus. Luckily for you, the quadratic formula would be given as in the formula sheet, but it's not too tricky. Remember, if you use it often. And this would all be over 2 times 4. Okay. You'd punch that into your calculator, and I've done so previously, and I got 2 answers for x. So the x for one was 4.25, or x could be negative 5. So those are the 2 x values. And once I have this x value, I can just sub it in there. That's probably the easiest one to do. And then I would get a y value. So the y value I got here was 4.25 squared minus 18 got me 1 over 16 on the calculator. Or 0.0625. You can use it, leave it as a fraction, or that's the other option. Maybe I should just not write those next to each other because it looks like I'm multiplying them. I'll just write here or 1 over 16. Both would be, or there, that would be 17 over 4. You can either leave it in a fraction or in decimal, that's fine. And this one got a nicer number. This y is just equal to 7. So yeah, I think that one is it's not the worst, but definitely one that can catch you out. Okay, let's go to the next question. Question 7 here. Let's take a look. So they're saying a solid bronze cone. Okay, so I'm going to draw the cone just for myself. There's a cone. There we go. And this cone would have a radius and it would have a height. Okay, beautiful. A solid bronze cone has a mass of 750 grams. I'll just write here 750 grams. And I know the density of bronze is 8.9 grams per cubic centimeter. And they're saying the ratio of the radius of the cone to the height of the cone is 1:3. So basically the ratio of let's say this is the height and that is the radius. So the radius to height would be 1:3. So basically if the radius is 1, the height will be 3, or if the radius is 2, then the height would be 6. Okay, so it's just like 1, 2, yeah, that makes sense. 2 to 6, 3 to 9, etc. Okay, first of all, show that the radius of the cone is 2.99. So we have show that it's 2.99 to 3 significant figures. And they're giving us an equation there saying that density is mass divided by volume. And they're also giving us the volume of a cone. And let's just write the volume of the cone here. So the volume of a cone is going to be 1/3 pi r squared to the height. Okay, so basically they're giving me the mass. So I have the mass and I have the density. So I should be able to work out the volume if I just rearrange. So let's quickly just do that just for interest's sake. So volume is going to be mass over density. I think there's a little, yeah, okay, no, usually these units aren't the same with these types of questions. So luckily they are the same. So we can just do the 750 divided by the 8.9. And that would give us, on the calculator, that is 84.269, 66, etc. Okay. And that is cubic centimeters. So I know now if I look at this equation, I have the volume. I needed the volume, so I worked out the volume. Pi I have, that's just like a number. I don't have the radius and the height. I have to show it. But what I do know is that the radius is like a third of the height. So the height is 3 times the radius. So I can write a little equation for myself here just to show that, let's say, let's just do a different color here. So in this equation, there are 2 variables now. So I can't really solve it because I have the volume now, but I can't solve this. So I'll need another equation. And that is the one that I use by saying, okay, well, if I take the radius times 3, that would give me the height. So the height is 3 times the radius. So now with this, I could actually sub in this into the height. And then we should be able to work something out. So I'm going to restart with 84.269. Just keep that on my calculator. 269. That is equal to a third pi r squared, and that is multiplied by 3r. And now it's just kind of rearranging this. So I'm going to divide both sides by, what am I going to do? Let's see. Oh, really interesting. This 3 and that third, they're just going to cancel out, right? 3 times the third is 1. So that doesn't really change anything for us. And then we would be left with pi and r cubed, right? So basically, I'm just going to divide both sides by pi. Divide by pi. And then where's my calculator? Let's say 84.269 divided by pi gives me 26.82. And that is going to be, that's r squared times r, so that's r cubed. So I just now have to take the cube root on both sides, and hopefully, where's the cube root button? Answer. That gives me, I'm just switching them around. This is 2.99345. And then showing that is, but what's really important, I can't just do this. This is very important. I can't just do this. Because they said show that to 3 significant figures, I have to put the other figures in here, how many there are, and then I'm going to show, okay, this is rounding off to 2.993 significant figures. So just be careful that you don't lose that mark for showing that it's that. The second part of the question was just calculating the surface area. So let's just rub this off and work out the surface area. And it should be straightforward. Let's go. So they did give us so the surface area of a cone, I'll draw the cone again here. There's going to be 2 parts. It's going to be the curved part, which is kind of this type of thing, plus the circle. And yeah, that would be pretty much it. So for this, on the formula sheet, you'll have this little formula sheet given, and it says the surface area of the curved surface area of a cone. There we go. That is going to be pi RL, and the radius, we know it is written on there, but we know that's pi r squared. And pi, and then the r radius is given as 2.99 times the length. Oh, okay, so that is the slant height, which we don't have because we have the radius. The radius was given at, okay, let me just do a little better little sketch here. So we did have the radius. The radius was given as 2.99, and the slant height is this one, And we don't have the slant height. We have the actual height. And the actual height was given as, well, this is 3 times the radius. So it's basically that height is going to be 3 times 2.99, which would be, let's just do 3.2. Oh, well, I should be able to do this without a calculator. But anyway, 8.97. Okay. So for this, okay, let's just color code this. This is the L. I'll make this the L. That is this L, slant height. And to work that out, it's just Pythagoras, right? So it's basically going to be the square root of 8.97 squared plus the radius is 2.99 squared, all squared. So this would be that. So I can put all of this in here. So that's going to be the square root of 8.97 squared plus 2.99 squared, all square rooted. Okay, that's the one part. And I'm going to add, oh, I'm running out of space here. So this is this. And I'll have to, let me just take this out. Don't need this now. Already did that. Plus the pi r squared, the pi, and the 2.99 squared. And if I work all of this out, I should get 116.9. And then to 3 significant figures, that would just be 117. Cool. So 5, wow, that was 5 marks. I felt that was not, I mean, I did put it in here because it's 5 marks, but it was an easy 5 marks, I think. I think the tricky bit was just seeing that the slant height we didn't have, so we had to go the Pythagoras root. Yeah, that's pretty much straightforward. Let's go to the next question. Number 8 here. The line intersects the graph at a point and find the coordinates. You must show you're working, give your answers to 2 decimal places. This is actually in here because it's 6 marks, but it's pretty much exactly the same as the previous question. So I'm going to just kind of quickly run through this one. For any time we have 2 lines intersecting, we'll write them, we'll basically do substitution. So the line, I'll just write this out because I know you can't see that. 5 minus 2x, and then y is x squared minus 3x minus 28. So this is the straight line, and that's the curve. And where they intersect, if I ever have to intersect them, I just say this equal to this. Very straightforward. 5 minus 2x equal to x squared minus 3x minus 28. Now, for a quadratic equation, we put everything equal to 0. So we got x squared minus 3x minus 28, and then I'll do a plus 2x and a minus 5 is equal to 0, and that would come to x squared minus x minus 33. Now, because it said this correct to 2 decimal places, I know I'm going to have to either complete the square or use the quadratic formula because I won't be able to factorize this. If it was factorizable, I don't think they would waste the ink and write there correct to 2 decimal places. So yeah, let's take a look. You could probably think about it. 1 times 11, well, sorry, 3 times 11 gives 33, but I won't be able to get to -1 with that. And that's kind of the only numbers I think can get to 33. Well, that and 1 and 33. So quadratic formula, so A is going to be 1, B is going to be -1, very important, and C is going to be -33. And if we sub that in, very important, negative B, and B is -1. So make sure you don't make that mistake. Plus, minus, that's fine. We have another -1 squared, minus 4 times A and C, minus 33. That all square rooted. And then we got 2 times 1. And if you type all of this in your calculator, you would get 2 answers for x. X is going to be 6.2662. You can obviously 2 decimal places would be 6.27. The other one is x is going to be negative 5.26628, which would be negative 5.27. And if you sub in this x value in there, You can do it in there, but it's just like more calculations. So just 2 times this value, 5 minus 2 times this value, and then you would get y, in this case, I have enough space left, would be negative 7.53 when you round it to two significant figures, and the y value here would be 15.5. So very important here is just these are coordinates, so you would put this as the x and that as the y, and then for the other line this would be the x and that would be the y. For this example, I'm going to skip through the a part because it's very straightforward. They're just telling us, hey, show that y is equal to x plus 2 and x minus 1 squared can be written as y is equal to x cubed minus 3x plus 2. And all you have to do is multiply this out. So remember there's two brackets of x minus 1, and then kind of you foil and foil again, or well, it won't be foil, but it's two brackets and three brackets, and then just multiply everything out. So that won't be very tricky. The tricky part is saying by drawing a suitable line, they're saying solve this equation, and they're giving us a new equation, and that equation is 2x cubed minus 5x is 0. And they want us to draw a line to solve this equation, which is a little bit weird. So I'm going to go back and remind you of, like, this is now something different, so it's not to do with this question. If they, let's say, make it easy. If we had one line that was crossing something like a parabola or a curved graph, what they'd maybe give us is like y is, let's say, x plus 1, and then y is x squared minus 3. So if we had an example of a line and a curve crossing, what did we do? We did it earlier in this video. We said, well, we'll just equal these to each other. So what we'll do is we'll say x plus 1 is equal to x squared minus 3. We will then rearrange minus x minus 1 is 0. And we'll get, okay, so that's squared. Squared minus x, and that is minus 4 is equal to 0. So then we would get this equation, and we would solve this, and we'd find the points where they cross. So maybe that's the line. So that would be the 2 points that we're getting. So we would have a line equation, a curve equation. We'll equal them to each other. We'll rearrange. We'll get this new equation. We'll solve the new equation. Now, in this question, instead of them giving us the straight line and the curve, and we work this one out, they did something different. They gave us the curve, which is, this is the curve. And they gave us the one that's already kind of combined, which is this one. And now they're asking for the straight line. So basically, if I look at this equation, this part has included in it this plus another line. And I'm going to have to pull those two things apart to be able to find that line. So hold on to your seats. This is going to be interesting. The first thing that I notice is that, okay, so this is an equation, right? The thing that makes this a little bit more tricky is that my curve doesn't have a 2 in front of this cubic part. So they actually made it even worse for us. But I can remove that 2 by dividing everything by 2. And this is an equation, so I can divide every term by 2, and it will still stay the same. Sorry about that. So x cubed minus 5 over 2x is 0. Now, there's a negative 3x, and this is a 5 over 2x. I can see this part and this part is the same. So I'm going to keep this on this side. I'm going to keep this as x cubed, and I'm going to put just an equal sign here, and I'm going to move this over. This is 2.5x, right? So 5 over 2. And I just move that over. And I'm going to rewrite, I'm going to minus 3x here, minus 3x. But whatever I do on one side, I have to do on the other side, minus 3x. And then I'm going to plus 2, so plus 2, and I'm going to plus 2. So what I did now is that this equation on this side is exactly what is written there. So I know this is the curve, and then basically this will be the straight line. But I I added this minus 3x and the 2.5x. So I would kind of just change this up a bit. This is going to be, if I have negative 3x plus 2.5x, this would be negative 0.5 or negative a half x plus 2 is equal to the x cubed minus 3x plus 2. And this is what I was talking about. We have a curve, and we have, so this is the curve, and this is the line. So basically all I need to do now is I have to draw this line. So this line is y is minus a half x plus 2. So what I have to do is plus 2 is kind of there's plus 2 there. And the gradient is negative 1. So, sorry, negative a half. So I go 1 down, 2 forward there. And 1 up, 2 would be there. And then I would just draw a line. And where they cross, I would just read off the values. And I already did this because drawing with this wouldn't work. But if I looked at the 3 places that they cross, sorry about that. If I read off the 3 places that they cross, the one would be at negative 1.6. If I go down, negative 1.6, the other one is at 0, and the other one is 1.6. So it's a bit of a tricky one. It does definitely, I love it, but definitely something that can maybe catch you out in an exam. So for our last question on here, we have this interesting shape. Let's take a look at it. Okay, so we have a triangle and a shaded part. And they're saying, show that the radius is correct to 1 decimal. They're giving us the shape. It's a triangle and obviously a sector. And there's a radius and there's 50 degrees. They're saying the diagram shows a sector, OAB, and the center is O, and the chord is AB. So that's on the circle. It's a chord. And the shaded segment, so that part there is 30 square centimeters, square centimeters, and show that the radius is correct to 1 decimal. So if I wanted to find that part out, what I'll have to do is I'll have to take the sector and I'll have to subtract the triangle, and that part would then be 30. So the sector part should be easy. I can just do 50 over 360 times pi r squared. I don't have the radius yet, so that's just there. For the triangle, I can do the sine, so we can do half of the radius times the radius, or the one side times the one side. So that's going to be radius squared. And then the sine times the sine of 50. So this is just something you get from the formula sheet. Let me see, where's my formula sheet? Here you have it. So the area of a triangle, it's half times A times B sine C. So basically just half times the one side times the other side multiplied by the sine of the internal angle. And there we have it. And this is going to be equal to 30. And I want the radius, and I see very conveniently I have r squared in both. So I'm actually going to do some factorizing. And here I would have 50 over 360. This is 50 pi actually, 50 pi over 360 minus, this is the sine, well, it's half the sine, half, and that would be it, is equal to 30. And then on my calculator, I would just go and say, well, I'm going to divide this whole thing on both sides. So it's going to be 30 divided by this whole thing. 50 pi over 360 minus sine of 50 over 2. And that would give me a number like 562.745. So that's r squared, but because I want just r alone, this is plus minus, but because I'm working with lengths, I'm just going to care about the positive value. And then I would get 23.7225,192. And it's important that I don't just write 23.7 here, but I write the whole number out and then show that, okay, this is one decimal place. It's going to be 23.7, one decimal place. So kind of have to show that step. So that was fun. The next part is the perimeter of the shaded segment. So let's just take a look at what that's going to look like. So for the perimeter, this is the arc length plus that side of a triangle. And for the triangle, I know that the radius is 23.7 now, so that I know. So if I wanted to, let's just make that B, very nice. Oh, I see I can't. Then I made my A, but no one could see the A. Let's just make that radius 23.7. Okay. So the arc length is pretty straightforward. That's just going to be 50 over 360 times 2 pi radius, 23.7. So that's kind of easy enough. And then for the next part, that's the length of AB. So this will be added to AB. Now to get AB, let's just do AB here. So I know AB squared is I'm going to have to use the cosine rule actually. So AB squared is going to be 23.7 squared plus 23.7 squared minus 23.7 squared cosine 50. Let me just double check. So it's a rate 1 squared plus the other squared minus, oh no, the minus 2. There's a 2 in here. Sorry, minus 2 times this 2. Yeah, so it's B. Okay, let me just double check it here. Trying to do this just out of my head. So A squared, that's the A squared there. The AB squared. B squared, got that part. C squared, it's the same value. Minus 2 B times C, which is just 23.7 squared again, and the cosine of 50. Great. So if I work all of that out, I should get a value, and if I get the square root on that on both sides, I'm going to get 20.03210. So this is going to have to go in there, 20.03210. And this in my calculator, sorry, I'm kind of going all over the place. So this part would be, on your calculator, you'll get 20.68215. And that part is plus 20.03210. It does make sense that they're kind of similar because it's just the one should just be a little bit more or different than the other one. So it does make sense that the curve, yes, sorry, got lost there for a second. This is the curve, so the curve is going to be more because that is the arc. And then this is the straight line, and if we add them, we would get 40.714. And if we wanted 3 significant figures like they always do, we can just do 40.7 and 3 significant figures. Okay, wow, that was a long video. If you made it all the way till here, like really impressive. I hope that helped you. Let me know if there are any other questions that I should maybe do, but I will post another video with some of the current tricky questions for 2025 that would be coming up next.